Hi, boys and girls. Today, we're going to use the distributive property to find the area of a rectangle. Okay? Distributive is a very special word because it has the root word distribute in it. And distribute means to share or give a little to each part. Okay? Area, as you know, is the space inside of a figure or an object, and we find the area by multiplying its length times its width. The formula for area is A equals length times its width. Okay? So you might be asking, why do I need to use the distributive property to find the area of a figure, especially when I can simply just count the square units inside the figure? Yes, you can do that. But sometimes the surface area of a figure is so large that using the distributive property, it helps make our lives a little bit easier. Okay? So let's take a closer look at what I mean. I have two figures here. Okay? Both have a very large surface area or many square units inside to count. Okay? So I want to break it down using the distributive property. That means, for example, if I take my first figure here, and I'm going to partition this into two smaller rectangles. So I have a rectangle here and a rectangle here. Using my distributive property, I'm going to make sure this rectangle has some square units and this rectangle has square units. I'm going to add the square units together to find the total area. Let's go. First, I ask myself, how many rows does this first rectangle have? Remember, we read rows going across. This is 1, 2, 3. So it has 3 rows. How many are in each row? Well, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There are 7 square units in each row. 3 times 7. That's my formula. That's my formula for area. Area equals 3 times 7, which is 21. So my first rectangle here has an area of 21 square units. Now I'm going to do the same thing over here. I'm simply going to ask myself, how many rows does this rectangle have? 1, 2, 3. Again, we have 3 rows. How many square units in each row? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3 times 5. So 3 times 5 is 15. So the area of this smaller rectangle is 15. Now I'm going to combine the two areas to find the total area of the figure. 21 plus 15 gives me 36. Area equals, or I should say, A equals 36 square units. Okay? And of course, I can always go back and count my square units on the inside just to make sure I'm correct. Here goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Whew, that's a lot of counting square units. Again, it's easier to simply use the distributive property to help me find the area of the total figure. Let's try with the next one. Again, it's a lot of square units here. So I'm simply going to partition this into two smaller rectangles. And I put my line right here and down the center. I ask myself First, how many rows are in this first rectangle here? 1, 2, 3. 3 rows. 1, 2, 3. How many square units are in each row? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There are 7 square units in each row. So my area formula is 3 times 7. 3 times 7 is 21. All right? The area of this rectangle is 21 square units. I'm going to come over here and do the same thing with this other side of my rectangle. How many rows do I have? 1, 2, 3. 3 rows. How many square units are in each row? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8. 3 times 8 is 24. Now I'm simply going to add the two areas together. 21 plus 24 gives me a total of 45. Area equals 45 square units. And there you have it. Using the distributive property makes my life so much easier to find the area of a total figure.